Here in the Tugan Hills, nature has unearthed the geological epoch known as Miocene. Somewhere around here, more than 5 million years ago, humans and chimpanzees are believed to have gone their separate ways.
When we began to work on the Miocene, we were told by a very senior person, it's stupid, because the ancestor has to be the Pliocene, not earlier. And what was interesting us is to go down in time, earlier in time, to find out how the features in hominids can be expressed and how they actually emerged.
Brigitte Senou and Martin Pickford led an expedition in the Tugan Hills in the year 2000. Kiptalam Chiboy was the local excavation leader, and one morning he was waiting for them with something in his hands.
And he brought this paper bag with his bits in it. And he had this funny smile on his face. And he took the bag and we looked at it and said, but it's a hominid. And it was a hominid.
When Kiptalam found these, he knew immediately what it was. Yeah, his knowledge is very good. He's worked with us for many, many years. We went to the site and immediately we found more pieces.
It turned out to be a previously unknown anthropoid ape, and it was clear that it had been bipedal.
The length of the neck, the size of the head relative to the shaft, all those features suggest to us quite strongly that Ororin was a biped for sure.
The species was called Ororin tuganensis and dated back 6 million years. Thanks to the find, bipedalism had been traced back to a time when, according to genetic studies, humans and chimpanzees parted ways. But it also put a dent in Darwin's savanna theory.
When we found the fossil plants, the leaves and the wood and so on, and all the fossil mammals, they all suggested that actually 6 million years ago the area was forested.
The Tugan Hills hardly resembled the supposed arena for a transition to bipedalism.
It was what we would call an evergreen dry forest. So there were always trees with leaves, green leaves on, and for 9 months of the year or more there would be fruit available. Ororin, who was fully bipedal, was living in a forested environment, not in a savanna environment.
If hominids walked erect in forests as early as 6 million years ago, we were most likely bipedal even before we left the trees. And if that's the case, the savanna theory belongs in the wastebasket.
Darwin, of course, pushed the savanna hypothesis. You have an ape from the tree coming down on the ground, walking around on 4 legs, like a chimpanzee or a gorilla or a baboon, and then subsequently standing up on 2 legs. What the new scenario is that the animals came down from the trees and they were already bipedal.
But what conditions up in the trees could have caused us to become bipedal? Well, studies of orangutans have shown that an upright posture does make it easier to pick fruit off the tree branches.
The orangutan provides a kind of an idea of how a large arboreal ape can adopt an upright position and extend its legs in a fully extended position, which is what humans do, and which was what Ororin did.
Ororin tuganensis may have marked the beginning of the evolutionary lineage of Homo sapiens. Or maybe it was just one of several erect species in the experimental laboratory of evolution at that time. Regardless, one thing was made clear by the creature that Kiptalam Chiboy discovered in the Tugan Hills. We had started to become human long before we left the trees. It's not easy to study the origin of language, but early clues can be found in primitive African peoples, like the Hadza in Tanzania. Clicking sounds may have been part of a first spoken language. Genetic studies have shown that 2 of the 3 most ancient peoples on Earth use clicks when speaking. But when did the ability to speak emerge? Which group of ancestors were the first to talk to each other? Could it have been Homo erectus? They manufactured tools, harnessed fire, and lived together as couples. Or did even Lucy and her kind utilize something we could call language? Studies involving our closest relatives today have shown that Australopithecus may have had more to say to each other than previously thought. Chimpanzees' physiology does not permit articulated speech, but they have other ways of communicating.
Chimp vocalizations can actually be quite complex in that they're graded along a spectrum. They can be loud, they can be soft, they can be long, they can be short, but they don't have as many vocalizations as they do gestures.
Amy Poddick has spent countless hours studying chimpanzees, and she's recorded a surprising repertoire of gestures.
I have found about 31 manual gestures that are used to initiate social interactions, and they range from tactile gestures to arm raises to extended hand types of gestures, all kinds of gestures. One of the reasons I started this study was because I noticed all humans gesture. They gesture when they talk on the phone. They gesture even if they know the other person can't see them. So what that said to me was that gesturing is so deeply ingrained in the human communicative strategy. And that's why I began to look for evolutionary precursors in the chimps.
Some scientists believe that human languages may have a gestural origin.
I think it's been natural to assume that language is speech, and that speech evolved from vocal calls. But I think that's wrong. I think it's much more likely that it evolved from bodily movements, and particularly movements of the hands. Have you got a coffee for me?
The gesture theory is controversial, but it's been supported by Amy Poddick's research. We now know that apes express themselves more with their hands than with their mouths.
We are finding that the same gesture can be used in many different contexts. And you just simply don't see that with facial expressions and vocalization. So that makes gesture a very serious candidate for the earliest form of communication that took on linguistic-like properties.
So their vocal calls nearly always seem to be elicited in emotional situations and are not under voluntary control. But their gestures are much more free, much more voluntary, much more intentional, and much more dyadic, and that means that they tend to be between individuals. And most language, of course, just like we are speaking now, is between individuals.
Could Lucy, a creature with a brain almost as small as that of a chimpanzee, have developed some kind of sign language? It's not impossible. Brain reconstructions show that Australopithecus had taken a decisive step away from apes 4 million years ago.
If you look at something like a chimpanzee brain, you can see the lunate sulcus here going around like this. And you can see that relative to the size of the cortex, it's in a very anterior position.
The brain's visual centre is far larger in apes when compared to humans. And we now know that Lucy's visual centre had started to give way to more demanding mental tasks.
The primary visual striate cortex is relatively reduced, and the parietal association cortex has increased. And what that suggests is that the behavioral capabilities of the Australopithecines were more advanced than what you find in apes.
Australopithecus may have had rudimentary language skills, and perhaps in the form of a sign language. However, we do know that Lucy did not have the power of speech.